We all know AI is changing everything, but it's got this huge appetite for power. A massive one. So what if the answer isn't here on the ground? What if it's up there, in space? Yeah, let's get into this. It's a wild idea.
Okay, so to put this in perspective, right now, data centers, the places that run the cloud and everything else, are already eating up somewhere between 1% and 2% of all global electricity. That's a huge number already. And with AI just getting started, that number is about to go vertical. This is the problem we're trying to solve.
So you have to ask, right? As AI keeps growing and we ask it to do more and more, are we just sleepwalking into a massive energy crisis? I mean, the very tool that's supposed to help us fix things could end up breaking our power grids.
All right, so let's dig into the problem a little deeper. Before we get to the space-based solution, you've got to understand just how bad the energy crunch is getting for AI right here on Earth.
So, why is AI so thirsty for power? Well, it's kind of a perfect storm. It all runs on these super power-hungry GPUs, right? They're the engines of AI, but they get incredibly hot. So to train a big model, you need these giant server farms that not only suck down insane amounts of electricity, but also need a ton of water just to keep them from melting. And we're literally starting to run out of places on Earth that have enough land, water, and grid power to build these things.
So with all these problems piling up on the ground, some pretty smart people, including folks over at Google, are starting to look, well, up. They're kicking around this really wild idea, sometimes called Project Suncatcher, which basically says, what if we just move the whole problem off-planet?
And the place they're looking at is low Earth orbit, or LEO for short. Think of it as the perfect spot, just a couple hundred kilometers up. A satellite there whips around the planet in about 90 minutes. And the best part? It's soaking in sunlight pretty much 24/7. No clouds, no night, just pure, clean, nonstop energy.
Okay, so how would this actually work? The concept is pretty straightforward, really. Step 1, you launch these compact server clusters up into LEO. Step 2, you unfold these huge solar panels to power them. Step 3, you do all the heavy lifting, all the intense AI processing up there in orbit. And step 4, and this is the really clever part, you only send the final answer back down to Earth. Not all the raw data, just the result. That saves a ton of data transmission.
I know. It sounds like something straight out of a sci-fi movie, but when you start to look at the advantages, it actually starts to make a surprising amount of sense, especially when you compare it to what we're doing now.
Just look at this comparison. Down here on Earth, you're stuck with the grid, which is often running on fossil fuels. You need huge tracts of land. You're using up precious water for cooling. But up in orbit, the power is free and constant solar. You use zero land, and for cooling, well, you've got the endless cold of space itself.
And it gets even better. The power potential is like an order of magnitude more than you could ever get from solar panels on the ground. Plus, and this is a big one, you can process satellite data right where it's collected. Think about what that means for weather forecasting, or defense, or mapping. And with companies like SpaceX making it cheaper and cheaper to get to orbit, this idea is moving out of the fantasy column and into the maybe column. Okay. Before we all start investing in orbital server farms, let's hit the brakes for a second. We need a major reality check here. Because as cool as this sounds, space is, well, space. It's incredibly hard, and this idea runs into some massive roadblocks.
The number one problem, the biggest engineering nightmare, is heat. Remember how we said those GPUs get super hot? Well, here on Earth, you just blow air or pump water over them. Easy. In the vacuum of space, there's nothing. No air, no water. The only way to get rid of heat is to radiate it away as infrared light. Think of a hot stovetop glowing red. It's super inefficient, and it's a huge problem to solve. And then there's radiation. Space is just swimming in high-energy particles, cosmic rays that are like tiny bullets constantly slamming into your electronics. They can fry a normal chip in no time. So you can't just send up a regular server. You need these special, super expensive, rad-hardened components just to survive the environment. And you also have to deal with the speed of light, believe it or not. It's fast, but it's not instant. Sending a signal up to orbit and getting an answer back takes a few milliseconds. For you and me, that's nothing. But for a lot of computer applications that need instant responses, a few milliseconds is an absolute eternity. So, no real-time gaming on a space server.
And finally, the big one, cost. I mean, come on. Even with launch costs coming down, we are still talking about an absolutely astronomical price tag to design, build, test, and launch something this complicated. The economics just aren't there yet. Not by a long shot.
This quote really hits the nail on the head when it comes to maintenance. What happens when something breaks? You can't just send a repair person up there with a screwdriver. People have compared it to those underwater data centers. If a server fails, you just leave it. It might literally be cheaper to launch a whole new one than to even think about trying to fix it.
So, you've got these incredible benefits on one side and these monumental challenges on the other. Where does that leave us? Is this the future of AI, or is it just a cool sci-fi fantasy?
Well, the general thinking right now is that this isn't going to replace all the data centers on Earth. It's probably going to be a very specialized niche thing. It makes perfect sense for jobs where the data is already being generated in space. Things like analyzing satellite photos for defense or crunching climate data from space-based sensors. It's a complement to our systems on the ground, not a replacement for them.
And that's really the key takeaway here. Think of this less as an immediate solution to the AI energy problem and more as a strategic experiment. It's about pushing the envelope, seeing what's possible, and developing tech that might be useful down the line. It's not a silver bullet for today's problems.
So no, we're not about to upload the entire internet to orbit anytime soon. But this whole idea, this grand experiment, it really forces us to think bigger about where technology can go. And it leaves you with this really fascinating question to chew on. As AI gets smarter and smarter, will its future home have to be somewhere else entirely? Maybe, just maybe, up there in the stars?